Broadcasting around the world. This is Engineering Tomorrow, the podcast committed to bringing you the best in commercial construction, design, and engineering from the brightest minds in the industry. This is the stuff they don't teach you in school. So sit back, relax, and open your mind. You're about to get the insider knowledge to improve your next construction project or advance your career. This is Engineering Tomorrow.
All right. Here we are, Engineering Tomorrow podcast, back for another episode. And we have a very special guest in the house, Matt Pefley from Spirotherm. Matt, how are you doing today?
I'm great, Brian. Thanks for having me here.
Great. And it's June right now. You're from Chicago. Is it still 5 degrees up there or what?
Yep, just had some snow. And
just shoveled, huh? So we're piggybacking off of last week's episode, which was on Flowtech non-chemical water treatment. And we are talking about now the actual dirt and air potentially within a processed water system. Matt, tell me a little bit about what problems are in your HVAC and processed water systems.
Yeah, so the most common symptoms are dirty water, which chemicals are definitely needed to help address that. Our point is that air is always a constant in there, so if you don't get rid of it, you can always expect to have a certain amount of corrosion levels in your system. The other problem is just typical no heat calls or just no flow to a building. And sometimes we'll identify that as you'll see gauges bouncing around a pump. You'll hear your pumps cavitating. However, you won't hear them on glycol. Glycol foams and acts as a sound attenuator.
Tell me about specifically what systems are we talking about here?
So your typical HVAC, chilled water, heating hot water, geothermal even, or process run a lot of factories and plants too to solve their problems.
Okay, so for some of the younger people listening, you've got your water loop with your chiller on it, and that's moving water around the building, right?
Correct.
So this is going through your piping network, and there are challenges to maintaining that water. Are you mainly working in the closed loop, open loop, or together?
We're both.
Okay. Let's start specifically with a closed loop. And closed loop can typically consist of what pieces of equipment?
Chillers, boilers, pumps, expansion tank.
Okay, and closed loop means what?
The pipe's all connected, that it's not literally exposed to the atmosphere.
Sure. So nothing from outside. Once that thing is running, nothing from outside is going to get into the water. Is that accurate?
That's spot on. Yes.
Okay. So we got this water moving through our building. If the water's clean, when you first put it in there, like what problems, like how is it getting dirty or what's happening with that system?
There's a couple of things that happen that we've seen from our perspective.
Okay.
Not every job has the pipes flushed out.
Okay. So improper flushing is one problem.
Right. But there's, LEED certified buildings that have problems with dirty water within months after them starting up, and they did have that flushing, it did occur. So why would that happen? Well, if there's too much oxygen in the pipes, you've got corrosion from happening. And the rate that corrosion occurs is going to be different from every system because water is different. The pH levels and the temperatures and the pressures that it operate at are all going to be different from one building to another. So it could, happen within 2 months of this building, but another building down the street, it could be 2 years before they start seeing corrosion.
If your water's not perfect, if it's not clean, if there's air in it, what problems are we going to start to see in the system?
The dirty water is the easiest indication, but there's other problems too. I mentioned earlier the no heat calls, on the heating side. You're not really going to see that so much on a chilled water system. The no flow, although that does happen, but you will also notice it on some of your equipment. So, for instance, if I'm supposed to be getting a 10-degree delta T out of my chiller or my coil, we find that air has an impact on heat transfer, and you may only be getting, 8 degrees out of it instead of your 10 or some kind of variation of that. So it's got a big impact with the efficiency, not just necessarily problems that we're so used to dealing with.
So we're losing performance on our equipment over time, potentially, in a closed-loop system. I would imagine it potentially could be even worse on an open loop, being exposed to the environment.
Right. You've got constant air coming in. It's almost pointless to try and address the air, although some of our clients have used air and dirt separators for the open side, where they've got such bad cavitation problems. But you've got constant corrosion, and that's something that you need to address with chemicals and proper filtration.
So how does Spirotherm solve or help remedy some of these problems?
Yeah, when we get to the air side, traditional air separators that are still probably 60% of the specs around the country are 1950s technology. And we're trying to get the word out for people to use 1970s technology.
Okay. What do you mean by 1950s technology?
So it's an older tank, tangential, they're often referred to, or centrifugal separators, where they're the pipe connections are offset. The inlet's on the top and exits out the bottom, swirling the water in a certain centrifugal motion, trying to make air bubbles escape through the center vortex. And doesn't really work well with today's technology. Pretty much every pump now has a VFD on it.
Okay.
So they have a certain sweet spot where too fast a flow or too slow, they don't work very well under those conditions. And they've also been VE'd, but I won't get into that. They're not the same as they used to be from the 50s and 60s either. But in any case, whether they're designed properly and they have all their media in them, they differ from the coalescing type that Spirotherm invented, because we get all air bubbles out of the water, and that's really the difference, where they could only get the larger bubbles.
Okay.
Spirotherm gets 100% air bubbles out, and you have about 99.6% dissolved air removed on top of it. So these aren't even bubbles. So less than 1% oxygen in your pipe is all that's in there. So it's not enough to be considered corrosive at that point. And that's the selling point to an owner. They don't have to deal with so much treatment, or they don't have to worry about their system eroding over time. They get extended life out of their equipment is probably the best way to put that.
Okay. For those of you who may have never seen a dirt and air separator, can you kind of explain what it looks like, what is on the inside, and how it works from that aspect?
Yeah, so probably a lot of people have seen, a dirt leg on a gas pipeline. Just picture a gas leg and then also another one on the top of the pipe too. So it's kind of this cross that's in the pipe, and it's full of this copper wire. It's a mesh, almost, I won't say honeycomb, but it's something like that in there. It's got millions of wires. And the term coalescing basically means that we're making bubbles stick to those wires. They're grouping in the same way that when you stick a straw into a can of pop or soda and you see all the bubbles cling to it. Well, that's what's going on.
Or on a beer glass, a lot of times the bubbles will stick to the side of the glass.
Exactly.
Which I learned means your glass is dirty. I've heard from some people. So if you ever go to a restaurant and there's bubbles all on the side of the glass, ask for a new one.
Noted. Thank you for that tip. So that's what's going on. It's called coalescing because we're slowing the velocity down. Basically what happens in that vessel is we've got a river going into a lake and then goes back into a river again.
Okay.
And that media is used to take the turbulence out. So it's making it very calm, almost the liquid's at rest, really. So that allows the bubbles either attach or just rise up because of their buoyancy. Same with the dirt particles. It really is like a dirt leg on a gas line. However, with water, you will have eddy currents that will carry the pieces of rust and iron oxide back out with it. So that media is needed to keep it calm in the bottom of that tank too, so the dirt stays there so somebody can flush it out.
So Spirotherm, you've got, like, you're the famous yellow tank on the system, right? It's like the bright yellow. And water's going in. It's hitting this copper media within the vertical tank and coming out the other side. Is this a side stream, or is this within your main loop? How does that work?
All of our case studies, everything, all of our success has been on full flow. Okay. We have been using side stream. It does work to some degree, but when you do that, you're risking some of the fluid going past it. So that's why these should be installed in full flow. And
does the air and dirt separator reduce flow at all?
It doesn't reduce flow. It's got and it has a pretty small pressure drop
Okay.
within it, so there's minimal impact on the equipment. But the one thing I'll just add with the side stream, air bubbles and dirt particles, they don't like to make hard right turns in the piping. So
Okay.
that's why side
That
stream
makes sense.
isn't that effective. You need something really to divert it through there.
How many people are competing in this space, and how would you differentiate your solution versus others?
There's been 4 or 5 that have been competing with us since the early 2000s.
Okay.
There's more coming from Europe, of course. Nonstop products from Europe because their economy isn't so well, and there's a lot of things being dumped here. I just kind of go back to how are they made? You look at cutaway pictures, you may be getting a strainer. When one already has a strainer at their pumps and terminal units, I usually ask, why do I need another one? How's it going to help me? Being a former maintenance guy. There's some other weird things out there, loosely filled rings. I don't disagree that these all don't remove air. I'm not saying that. It's do they remove to the level that Spirotherm does where we stop corrosion? And that's what they still have yet to prove. There's no, there's pointing to an independent testing that they've done, which we vetted that test, and it's flawed. It's not really that independent anyway. Spirotherm has a lot of case studies.
Okay.
26, or actually 27 now, I think, where we've got independently tested field results of, more tonnage, saving fuel, pumps slowing down if they're on VFDs, nuisance calls going down, chemical treatment going down. I mean, we've got a laundry list and multiples of it. So we've got multiple examples of Spirotherm actually getting it done in the owner's best interest, whereas a lot of these others just have come along to say, oh, we can do that too.
Me too, yeah.
Oftentimes they're a little bit less in cost than us, but if you look at how they're made, they're not filling it, completely, or they're using inferior products. And if we could get away with not filling up ours completely, we would have done it 20 years ago. But the reality is that's the way it has to be. Otherwise, it's not efficient.
Sure. Are you allowed to share some of the buildings or locations where Spirotherm's installed?
Yeah, I don't think we have any restrictions on too many.
Where are some places you guys have this?
Well, the world record is at Mizzou.
Okay.
There's 36-inch on there. I think it's the East Chiller plant there.
Okay.
And they got numerous large ones on that campus.
That's a state college in Missouri, for anyone that doesn't know.
Missouri State University will only accept these. So we're in higher ed's probably our biggest market, but we're in hospitals and K through 12 too. Let's see, the University of Nebraska has the largest units in parallel. That's a world record. They like to say they have the biggest pair in the world. So it's good.
It's good marketing pitch there.
But having the biggest in the world is fine to brag for a few seconds. But the bragging rights is, why do they have them? Because those are campuses that have hundreds of smaller units that fix their problems. And then they saw some of the energy savings and the efficiency gains, and that's what led to these industrial size units, those campuses.
Okay. Do you guys have any patents on what's inside the unit, or how does that work?
We still will always own the patent. However, I believe the patents are, the time's expired. So I think.
Okay, so they're a while ago.
So I think our competitors have had plenty of opportunity where they could have made something similar by now, but they choose not to.
I mean, I've seen the inside of a Spirotherm unit, and it is a very intricate. I mean, it's impressive how that whole thing, all the mesh is welded together or soldered together. I mean, is that all done by machine, or how does that work? Yeah,
I mean, if you actually get the chance to physically look at one, if you imagine somebody trying to solder that, they'd be blind after about an hour. There's so many little pieces. So yeah, it runs down a lathe, which is just a big machine that spins the pipe, and there's 2 copper wires soldered around in an engineered pattern, and it's really cool for about 30 seconds, and then after that, I'm like, what's next? Right.
Matt, I'm interested in, you mentioned case studies. Can you give us some data on any of those and what those successes were like?
Yeah. We've got millions of these in North America, and why don't we have millions of case studies? It's because rarely are we the only piece that goes in on a retrofit or new construction, of course, but it's a lot of people don't have the metering involved or really paying attention, even if they do. So it's been very difficult, I'll just say, to get this information. But what we found in solving people's maintenance problems is that there's some big energy gains to be had.
Okay.
One of those was Youngstown State in Ohio University, where they added us to their chiller plant. And the problem was they weren't dehumidifying at their air handling units, the farthest ones away from the plant.
Okay.
That's where the most air bubbles were going to collect in your system, and they were getting caught in the coils there. So we solved that problem. They got the air out of the pipes, and of course they were able to cool that building down and get rid of the odor. But as a result of getting the pipes out of the evaporator tubes, they got a higher delta T out of their chillers, and they also got more tonnage out of their system. So for somebody that's got a building where they're going to add on or have some kind of upgrades, that could potentially save them. In that case, it was almost a 16% increase in tonnage. Could possibly save them from having to buy another chiller, at least buy them some time anyway. They also saw their pumps slow down almost in half because there was so much air in that system. And we've got numerous examples of pumps slowing down if they're on a VFD for two purposes. When you get the air bubbles out of the impellers, you've eliminated that resistance in there, so they don't need so much pump energy to circulate that fluid.
Okay.
So that's one way they slow down. They just simply don't have to work as hard. But the other way is when we talk about heat transfer, those air bubbles in the water act as an insulator. Just like double pane windows or triple pane, there's a gas in there. If you have air in your system, it's slowing down the rate that you achieve your heat transfer, simply meaning that equipment has to run longer. What we found is that the pumps will slow down when you get the cavitation out, but they'll also slow down even more because I can still deliver the same amount of BTUs as I was before, now that the air's gone, and at a slower speed, just having those air bubbles out of the water. So there's that. Just some other examples were boiler fuel went down by 8%. So again, you can have the highest efficiency equipment out there, but it's like having a hybrid car with your tires improperly inflated. You're still not going to see its peak potential, and you really can't expect your equipment to run at its optimal level if you've got air in there.
We installed some pumps at a building out it's in Missouri, and the pumps kept breaking. In fact, we went through 3 separate pumps. So we go out there. There's several different theories as to why they were breaking, but we'd go out there, install a new one, leave. Same thing happened 3 times. So finally on the 3rd time, we installed it and waited and turned the system on, and a giant slug of air went through, shook all the pipes, shook the pump, and luckily they were able to turn it off before there was any damage. Come to find out, they had just had a manual valve to release air. So no air in the entire system was ever going to get out of there unless someone physically opened a valve. Why anyone would design it that way, I don't know. I wouldn't think it'd be that more expensive between a manual and an automatic air valve, but it's a real thing, and it could cost thousands of dollars if you get air in your system.
And it's costing people thousands, if not millions, every year, having to replace pump seals and other components for something that could easily be fixed. The problem in our industry is that little is known about what we do. The air separator is not code to have, and I still see commercial heating systems that don't have them. They heat the building, but it's not operating so well. We still see chiller plants designed without them. I know, some designers just say, "Well, I don't need one. I've been designing my plant for 30 years without air separators, and because we just don't have problems with air." But
the corrosion could be slow, though, right? So it could be like they may not necessarily see what's going on in there,
right?
And it may take a long time for that to get to the point of failure, where you have a big problem had you just taken care of it to begin with.
In their defense, there is a disconnect between a lot of the field staff and the designers. They don't get feedback that we're having air problems in
Sure,
the design because
yeah.
systems are working. We meet with a lot of maintenance guys that don't know that air can be fixed, and that's another reason why they don't tell the engineers, is because this is just everyday business for a maintenance guy. I'm going to go and bleed air, get the system flowing. I'm going to address dirt with side stream filtration or whatever I got to do, and things go on, and I'm about my day. But we have to show people with our demonstration unit, and I hope everybody gets a chance to see that. We can show you that a hydronic system can work without an air separator just fine. It can have a lot of air in it, still will circulate, and but we can show that air can be fixed. It's a problem that can be solved, and it can lead to a lot of energy savings and operational cost slashed as well.
Maybe you can give me an estimate on like based on a certain size system. Like, what are we talking to add something like this?
Are you talking about going from like the added cost to go from a traditional air separator?
I'm saying nothing.
Nothing.
Or I don't know. You tell me.
Yeah.
What both ways?
I'll give you both. So 4-inch is probably, the most common.
Okay.
That we see across the U.S., probably 4 or 6. But I'll give you a 4-inch example. So a tangential separator, a 4-inch, a contractor without a strainer, a contractor would probably buy for around $700, somewhere in that range.
Okay.
We make a unit that just removes air, does not remove particulate, and that a contractor would probably pay around $1,500. So it's about double the cost.
Okay.
To go with our combination air and dirt, and that's what most people buy, even if they don't have a dirt problem. They just want the added protection in that system. It's probably around $2,200, somewhere in that range.
It's actually a lot less than I thought. I mean, you're talking about keeping your system, at maximum performance, or at least helping to do that. It's reducing the potential of corrosion. You're talking 10, 20 years, that's nothing, That's a no-brainer.
You're going to pay $100,000 for a chiller.
Right, exactly.
But, you don't spend an extra $1,000 to protect it. That's what we give to the owner, and also for the contractor, too, because you're not going to be coming back to deal with warranty issues that potentially see.
It's a lose for everyone. It's a lose for the end user. The contractor's now in his time trying to figure out what the heck's going on. And they're probably calling reps who, supplied equipment, yelling at them. It's a giant chain and a disaster where we're just, let's just handle it at the beginning and not have to worry about it.
Yeah, Brian. I mean, it's like less than 1% of the mechanical cost for our air separators to go in. So it's still a drop in a bucket, 9 times out of 10. Labor cost is, there's not a lot required to put these in. I mean, often you can just cut out a section of pipe and weld on 2 flanges or screw on or what have you.
What for like a 4-inch? How many hours was that typically take? Do you see to install it?
If it was a retrofit, if that's just what they were doing, it'd probably just be an 8-hour day because somebody has to drain down the system. And but to cut it out and weld, it's half the day is going to be getting their equipment in there and taking it out.
Sure.
But it's minimal. It's not
about a day. So
yeah. I mean, if it's new construction, we're talking a couple hours, if that, because they're already in there anyway.
Is Spirotherm, are you kind of focused on this product alone? Do you do other things? Is there anything coming out in the future? Where are you guys at right now?
Right now, we're focusing more on the energy side because people want to know, is there a way for me to measure how much air I got in the system?
Okay.
And can I put a price tag, especially the ESCO or the energy service contractors out there really want to know those numbers. And we're getting there. I mean, we just came out with an energy model recently within the last year, and that's based off of our case studies, and that just kind of helps put a dollar sign on for the owner, what kind of ROI are they going to get with this equipment. And average is about a year on new construction. It will pay for itself in a year or less.
Okay. Tell me how this calculator works. Let's say I'm asking you to give me my return on investment numbers. What do you need from me? to get that?
We're not there quite yet.
Okay.
At that.
It's coming.
I mean, I've actually got the numbers from Youngstown State where somebody gave me their, and I can do this for chilled water, their electric rates, their flow, their chiller tonnage, and how many hours a year their pumps operate. I can give them a pretty good estimate.
Okay.
On just the pump energy alone, which that will probably be a 3 to 5 year payback in itself.
Okay.
But the metering, getting the whole system, we're still working on that. And it's because of some of the actual equipment out in the industry for measuring bubbles isn't all that accurate, we found. So,
okay.
So we're getting there.
It's an R&D.
Yeah. This is just in the infancy of the next generation of air separators. I mean, this is something that was developed actually in the 1940s to solve maintenance issues. And in the 1970s, the coalescing came along, but we're still addressing with dirty water, no heat calls. And now we're just seeing, because people have said, hey, you've changed my system, you've done something different, it's operating so much more efficiently now. Now we're understanding the energy side to it.
Sure. Without naming other brands, have you guys done side-to-side comparisons at all to see what the differences are?
Of the older style tangential, yes.
Okay.
We just did that about 2 years ago. We bought one off the street, took it in our testing lab, and we actually tested it along with the spiral vent. So that way nobody could say the spiral vent saw different water or had different amounts of air. They were in the same water.
Okay.
The tangential had the first chance at removing the air, then it would go through the spiral vent, and we just measured how much they removed. And the older style did remove air for roughly about 20 minutes, a lot of it, then a little bit for a couple hours, and then it stopped. Whereas 10 hours later, the spiral vent's still removing micro bubbles, and that's just what they're not able to get out.
So where you're going is the Spirotherm solutions are going the next step, and they're removing the stuff we can't see, it sounds like, or the ones that are really small, where the other ones are not going to get to that point.
Yeah, they were just never really designed to in the first place to get that. Never were capable of it, but we've never known. But that's what we replace out in the field almost all the time, is one of those older style air separators. So we know they don't get enough out.
Sure. Is there a story behind the famous yellow paint?
I don't know, but it does brighten up a mechanical room, I'll say that.
Yeah, so it looks like a minion from Despicable Me. I think it's good branding for sure. You always know when you've got a Spirotherm in your system.
And there's definitely some boredom out there on the construction sites because we've seen people decorate them as minions too. So,
well, you know what you should do? You should offer a dress-up kit. That'd be a good upsell. I'm not going to charge you for that idea, by the way.
That's a good route for you to go. Nice side business.
There we go.
You're listening to Engineering Tomorrow. Always striving to bring you the best in commercial construction, design, and engineering.
So there's been some rumblings about magnet technology for dirt removal. Can you speak to that? And are you guys doing anything with that?
Magnets are popular in Europe and in the UK in particular because they have a lot of open systems out there. So it's no different than the condensing side, except these are people's heating systems. They're exposed to air. They've got steel pipe. They've got a lot of corrosion in there. So the magnets are more attractive if they're going to get more dirt or debris per pass. And so now they're being introduced over here, especially with the residential, like commercial market in particular.
Okay.
Which is kind of funny because most of the residential market uses a lot of PEX plastic piping and
sure. Well,
and
they
copper.
do now for sure. Yeah.
But there's a lot of fear and scare tactics with these new ECM pumps with their magnetic rotors. They're going to pick up this ferrous oxide material in them. So that's where it's coming from. We don't really need them. Well, we have them in Europe, of course, because we have to have them over there. People think that they have to have them. But if you look at our before and after dirt samples, we do not need a magnet. We get out dirt down to 5 microns just fine. And there's such a demand, though, again, from people thinking that they must have these. So, but it's really not needed. It's added cost. And if you look at the magnets, they have such a small surface area. They don't really collect a lot of debris either. So there's some fundamental problems with the designs that are out there. They are good. They will pick up more dirt, but it's really not the right way to go.
How do you clean the magnet, or does the magnet need cleaning? How does that work?
Yeah, so it's still got to be maintained, and you, depending on whose it is, because some of them you have to shut off the flow to it, which could be a problem.
Residential, I'll just tell you, I don't see anyone cleaning that. Once it's installed, it's gonna be like that for the next 15 years.
Yeah, they don't. We try and tell contractors that that's a good opportunity to come back and do a clean and check.
Yeah.
Just like they do with furnaces or boilers. But reality is they don't. So we try and educate, they can get it cleaned up during startup for the most part, usually. But yeah, it's one more thing that has to be checked. And like I said, a lot of designs out there, they have to shut off flow in order for you to clean it. So that's the problem.
Okay. So you brought up a very good point, which was maintenance. Let's jump back to commercial. And we've got a Spirotherm unit installed. What do we have to do with this thing, and how often do we have to do it?
That's one of probably the top 3 questions I get. Price, pressure drop, which is pretty small, and how often do I need to blow these
How much
things?
work is this going to cause me, Matt?
Yeah. And I know you can't see me right now, but I'm kind of shrugging my shoulders. I don't know. It depends on how dirty your water is.
Okay.
So we don't have a schedule on purpose. We don't want you flushing clean water down the drain, especially if it's got chemicals in it, because when you add makeup water back in, you're adding in a certain amount of air back in your system. But if you have really dirty water, then it needs to be purged, daily, if you can get to it, until it starts showing signs of clearing up. Semi-clear, then you can start backing it up.
How do you know?
The best way is to visibly inspect. So if you got it just piped right into a floor drain, you're probably not going to see it so well because mechanical rooms are pretty dim. The best way is to get a white bucket, or even an orange bucket works pretty good too. See what's coming out of it. The water's dirty.
So on the bottom is a valve, right? That's going to open.
There's a ball valve.
Okay.
Right. Which this can be automated too, but really not necessary. But you just purge it, and usually by the time you open up the ball valve, it's time to close it. So we're talking a couple of gallons at most. Mm-hmm. You're not losing a lot of fluid. Most of it, that crud or particulate should be flushed out. If you've got a really nasty system, then maybe you need to extend the time that it's blown down, but not much. And just keep checking it until you're getting less crud out and the water starts clearing up.
So you get it installed, it's running. It sounds like after maybe a month or two, you get a pretty good idea of how often you need to do anything with it, if at all.
If somebody's checking their system right after startup, they can get that building even up to a 10-inch, 12-inch cleaned up within 1 to 2 months.
Okay.
Once they get it clean, they only need to check it once or twice a year. So probably right after a startup would be a good time. The system's been sitting for a while, like a heating system. It's been sitting all summer. You start it up in the fall. Maybe something settled. You kicked something up. That would be a good time then. But that's about it. It's the media doesn't need to be replaced. That's another question I get.
I was going to ask that.
because we're filtering. No, it forms a tarnish on it, and it acts as a protective layer, so that copper media is pretty durable. It holds up quite well. 20 plus years, some of our customers have said, and that's if they're maintaining it, though.
Sure. Why copper?
Well, it's one of the most durable products or industry proven products used. I mean, copper pipe's been used for, I think since the Romans.
Sure.
But, hydronics in North America last 100 years plus. Mm-hmm. It's also easier. It's definitely easier for us to manufacture that pattern. It works very well for us.
Do you have any that have like a sight glass on it that you can see inside?
Yeah, there is a brand out there that does have the sight glass on them. we've been asked for that. Why don't we do that? And I've seen one of those sight glasses. Anybody knows boilers, seen what the sight glass at your low water cutoff looks like.
Mm-hmm.
After some time, it starts to scum up, and the same is true for that. So
it renders useless at some point.
Right. So it's probably good for startup. I can't dispute that. But the one I saw had just a layer of scum over it, and it wasn't useful.
It's like
anymore.
your oven. You first get an oven, it's crystal clear. A year later, you can barely see through it, and then you got to spend an hour scrubbing it, and that makes sense.
Right. But, there's different gimmicks out there. It all goes back to, well, I won't call that a gimmick, but different flavors, different designs, different methods for trying to make coalescing, and there's still only one that has a laundry list of case studies, and that's us, until somebody can prove that they've got something that can increase tonnage or fix the no heat calls, then, where are they? They've been around a long time.
Let's talk about lifespan of the unit. Tell me, how long do you guys have these rated for?
The steel units come with a 3-year warranty.
Okay.
That's a standard, always has been. Typically, others out there have a 1-year warranty. And how long should these last me? Like I said, easily 15, 20 years. And theoretically, they should. If they're taking out all the air and somebody's purged them periodically, they should last a long time.
So a couple grand for 15, 20 years. I mean, you can barely even measure, the cost on that. It's nothing.
Yeah, the higher education now is focusing. They're coming out with a new standard, their own standard on construction projects, and it's called the total cost of ownership. So they're tired of getting inferior products because everything has to be a competitive bid. Mm-hmm. So what they're trying to do is get something that, the first cost is important, but what's it going to cost me to maintain it over the lifespan of this building? Do I have any cost for getting rid of it at some point and replacing it? Is there any licensing, like with controls? There's all these little costs that are added in, and there's going to be some kind of point structure.
Interesting.
So that they actually get good quality products on day one, because the money isn't there, but they're finding out they don't get the budgets. And Spirotherm ranks really high on their point structure right now, because when you look at the total cost of ownership, this product has proven itself time and time again to be in the owner's best interest.
Matt, where can we find Spirotherm? How do we get in touch with you? And then how do we see one of the famous yellow Spirotherm units?
Yeah, so all of our reps have their own demonstration unit. So I would say seek out Midwest Machinery. Talk to your sales guy there. Also, you can go to our website, spirotherm.com, and find us from that point. But we would like for you to work through Midwest Machinery, really set up a time, and if they can be out, to be glad to do a presentation or even a short 10, 15-minute live demonstration.
And man, I will say I've seen many presentations. I think yours is one of the best. You're in the top 3 for best presentations, so I'm going to give you that.
Well, thank you. If we just showed pictures and catalogs of our air and dirt removal, we would not have so many projects. That's for sure. It's led us into a lot of mechanical rooms, a lot of quotes, and it's because of that demonstration. We can actually really show. We teach. We don't even really have to sell. We teach people what goes on inside the pipes that we can't see, and it's such a good tool for showing hydronics problems that it's just a great visual.
Can you kind of describe that demonstration unit, what it looks like?
Yeah, so it's about the size of a suitcase. It's got clear pipe, and we have a circulator, and we've got a air and dirt separator, a small one, of course, and we inject air into it with basically a bicycle pump. Mm-hmm. So we're simulating where the air comes from, which is makeup water, and we can hear the pumps cavitating. We can show that the system still moves even with a lot of air in that mixture, and you can see the Spirotherm removing it. And then we can also inject simulated dirt. We've got this media in there, really good imitation of rust. And you can watch it remove both air and dirt at the same time, just like it would be in a regular building.
Great. Matt, thank you again for being on the show. Matt Pefley with Spirotherm. Thank you all for listening today, and tune in next time for another episode of Engineering Tomorrow.
Thanks for joining us on Engineering Tomorrow. If you liked the show, please take a moment to subscribe on iTunes or Spotify. For even more great engineering or construction knowledge, visit engineeringtomorrow.blog.